Assalamu alaikum viewers, welcome back to my channel Islam Education and Tech. Today we are going to cover the Boyles law. So first of all, let us see the introduction of Boyles law. So the Boyles law was introduced by Robert Boyle, who built a relationship between pressure and volume by keeping the temperature constant. Now let us understand this by an example. For example, you are having a container with a movable piston and you apply pressure on it by keeping some weight. For example, the pressure is 1 atm, atmospheric pressure. This is the volume of the container. For example, it is 1 decimeter cube. Now, if you apply pressure on it, more pressure on it, for example, you double the weight, so the pressure becomes 2 atmospheric pressure, 2 atm. As a result, the volume is decreased and it becomes 0.5 decimeter cube. And it is in a case where the temperature is constant. So this was the relationship which Robert Boyle built between the pressure and volume by keeping the temperature constant. That if the pressure is increased, the volume will decrease. So the pressure is inversely proportional with volume. Now what was his statement? The volume of a given mass of gas is inversely proportional to its pressure if the provided temperature is constant. As we know that when we increased the pressure, the volume decreased. So the pressure and volume have an inverse relationship when the temperature was constant. Now the mathematical form. How can we write is that the volume of a given mass of gas is inverse means 1 over mass, 1 over pressure. Inversely proportional. This is a sign of proportionality to its pressure if the provided temperature is constant. Yani if the temperature is constant. How can you further write it? That the constant can be written as K. So V is equal to K over P. Now, as you know, now this P is dividing here, so it will go and multiply there. Vp equals to K. And now, this is another form of writing the Boyle's law by keeping the temperature constant. The volume of a given mass of gas is inversely proportional to the pressure. If you got a short question about the Boyle's law, then you have to write the introduction, statement and mathematical form. But if the Boyle's law is asked in the long questions, then you have to go further. Now, there is also another form of writing Boyle's law. So the Boyle's law can also be stated as the product of pressure and volume when the temperature remain constant. As we did that, the product of pressure and volume when the temperature is constant. So in this case, we can write as P1 and V1 is equals to K and P2, V2 equals to K2. For example, in this case, if the P1 is the initial pressure, and V1 is the initial volume, then P2 final pressure and V2 final volume. If we get the product of initial pressure and initial volume and then calculate the product of final pressure and final volume, we will always get the value of K, and the value of K will be equal to the value of K2, K3 always. So the product of initial pressure and volume will be equal to the product of final pressure and volume. This is another form of Boyle's law. Now let us do the experimental verification step. This is the first container. It is having gas molecules far away, far apart. And the pressure of this container is, for example, 1 atm. And the volume of this container is 8 decimeter cube. Now, if we double the pressure, for example, 2 atm, and the volume, then the volume of this mass will be 4 decimeter cube, because it will be halved. If we again double the pressure, for example 4 atm, now the volume will also be halved, and it will be 2 atm. If we again double the pressure, for example 8 atm, now the volume will also be halved, and it will be 1 atm. So you can notice that when the pressure was 1 atm, the volume was 8 decimeter cube. If we double the pressure, the volume became halved, 8 divided by 2. Again, when we doubled the pressure, the volume again halved, and when again we doubled the pressure, the volume became half. So in this place we can write that initial pressure P1 multiplied by V1 is equal to 8 ones are 8, P2 multiplied by V2, P2 multiplied by V2, 2 fours are 8, and it is equal to 4 twos are 8, P3 multiplied by V3, and it is also equal to the fourth container P4 multiplied by V4, 8 ones are 8. It's verified that the pressure and volume are inversely proportional. When we multiply P by V, we get the answer K. Always the answer is constant. 8 ones are 8, 2 fours are 8, 4 twos are 8, and 8 ones are 8. Now let us move to the graphical representation. Now we are going to do the graphical representation of the Boyle's law. On y-axis we put the volume, and on x-axis we put the pressure. So when the pressure was 1 atm, the volume was 8 decimeter cube. So we can do it like this, just like this. Now when the pressure was 2 atmospheric pressure, the volume was 4 decimeter cube. Means that we can write it as this. When the volume pressure was 4 atmospheric, the volume was 2 atm, just like this. And when the pressure was 8 atm, the volume was 1 decimeter cube, just as this. So now we will join all these dots. Wrong. This is the graphical representation of Boyle's law. Now the result, when we calculated the product of volume and pressure for this experiment, the product is P1V1 equals to 8. Second product multiplied by is equals to 8, third product equals to 8, and the fourth product also equals to 8. So this was the Boyle's law.